we talk about question 21, chapter 6. Let's see. Yeah. Parts manufactured by an injection molding process are subjected to a compressive strength test. 20 samples of 5 parts each are collected, and the compressive strengths are shown in 6E12. See, we have 5 observations for each sample. We have Xbar for each sample, and R computed and listed in the dataset. Okay, so we want to establish Xbar and R control charts for compressive strength using these data. Is the process in statistical control. So we open up the mini tab. We upload the dataset if we don't have it, but we already have it here. First thing you should do is you should look at the dataset, how it is given. Let's see. See, 21, so there are 20 here. I can open up big as well. Here you see. Okay, example 21, A sample. There are 5 of those first sample, second sample entries, third sample entries. There are 5 of them. And the data is entered in one column, as you see. Okay, 5 of them first sample, 5 of them second sample, 5 of them third sample. So you want to first understand that. And this is the Xbar part, Xbar computation. That corresponds to 20 of them. There are 20 of those here, you see. There are 20 of those Xbars, and there are 20 of the R here, as you see, like R20. I should also tell you that there's another 21B sample. In part B and C, they are gonna give us 10 more data set. See, this is gonna go up to until 10 or 15, I guess. I think 15. Yeah, 15 more data set is gonna be given to be added. Its data is given in C59. I mean, this the sample numbers, and then C60 it's the data set, and in C61 it's the corresponding Xbar. In C62 it's the corresponding R values for that extra 15 samples. So we will answer our questions now. We are going to go to stat, we are going to go to control charts and variable subgroups, Xbar-R chart. So we have an option, all observations for a chart are in one column, all observations for a subgroup are in a row of columns. Actually the first one is true. Okay, so we are going to select we are going to select this 21ASD because 21A sample shows the sample numbers. So we select this, and subgroup sizes in each subgroup or in each sample we have 5 observations. That's why this is 5. And we don't do anything with the others, but we want to look at Xbar. These are from the past, so I'm going to erase them. In the estimate view it's going to be all clean. Limits, don't worry about that. Tests, so there are 3 options: perform all tests for special causes, perform selected tests for special causes, or perform no tests. So we are going to perform all of the tests. Of course we are going to use the most important ones. This is like test 1, test 2, test 3, test 4, test 5. test 6, test 7, test 8 of those. But so we are gonna mostly be discussing the first test 1 results, which is this: 1 point is greater than k standard deviations from center line, and our k is 3 standard deviations, right? So we wanna, so this this is about the out of control limits, out of control points. Here 9 points in a row on same side of the center line, if this is the case, right? Then we have a failed point, 6 points in a row, all increasing or all decreasing, and 14 points in a row alternating up and down. These are all going to give us failed situations. 2 out of 3 points greater than 2 standard deviations from center line, 4 out of 5 points greater than 1 standard deviation from center line, 15 points in a row within 1 standard deviation of center line, and 8 points in a row greater than 1 standard deviation from center line. So these are the test stages. We don't do anything about it. Box, Cox, we don't do anything. Display stays like that. Do not split all. Display test results in session window. We are gonna keep track of that test results. And storage, we don't do anything. Okay. Click OK. Everything looks okay. Let's see whether we have any problems with the points. Observation, samples. So we have the Xbar-R chart. I enlarged the screen and we see Xbar-R chart, and everything looks, so there are, let's see, 20 samples here, and this is the sample mean, this is the Xbar chart, and all points are in control, and this is the, again, 20 samples and R chart, all points are in the control limits, so everything looks fine. You can change the name, okay, to add title. Charts for the first 20 samples, okay, and we can keep it like that. Save that. Sorry, ignore that. Okay, so keep it there. And so let's go back to our question. Alright, so everything looks fine. Our process is in control. There's cyclic patterns in the averages. That's true. You see that cyclic, like 3 and then 3, okay, and then 2, 3, okay, 3 and then 2. Yeah, there's cyclic pattern in the averages, so we observed it. Anyways, so let's see part B. After establishing the control charts in part A, 15 new groups subgroups were collected, and comparative strengths are shown in the following table. The question is, plot the Xbar and R values against the control units from part A and draw conclusions. So we have, as you see, 15 new samples, and each has the same observation number, 1 to 5. Okay. So we are going to do the same. Okay, so we are going to go to so what we are going to do, I'm going to go to I'm gonna go to C59. Okay, I'm gonna copy paste it, copy cells. I'm gonna put it underneath C55. Replace the active cells, yes please. So I entered that. So we have the sample number here. Okay, next 15. So I'm going to I'm gonna build my control chart again, but I'm gonna the same set, but this is changed. I added 15 more samples. Subgroup size is 5, and these 4 options are okay, it stays the same. Xbar-R options, it's gonna change. For the mean and standard deviation, I need to go and calculate that. Okay, so this is for 20 samples. Okay, okay, so mean is 79.53, and then standard deviation for the first 20 samples, it is R bar over D2. Okay, R bar over D2. R bar is 8.75, as you see. That's what we found. And then D2 is, if you go to the table, we see that it's 2.326, and this is equal to 3.7618. Okay, so I'm gonna copy paste that. Okay, so the standard deviation is this. I want to keep the control limits, so I want to the mean is 79.53. okay, and then the estimate, use the following subgroups when estimating parameters. Even if I have 35 samples now, I'm gonna just have the control limits according to the first 20 samples. So I'm gonna write 1 to 20. Okay, and nothing to do here. Tests, I already closed all tests, perform all tests. Stages, nothing, nothing, nothing here, nothing here. Okay, click OK. If I didn't do these 2 steps here, then it would, the control limits would change. Okay, so I want to use the control limits in the first part, in the first 20 samples. I'm trying to build fix suitable control limits. That's why I have to work on my first 20 samples. Okay, so let's make it enlarged. So it says at least one estimated circle parameter is used in the calculations. Subgroups used for calculations 1 to 20. See, we have see, Xbar is still 79.53, R bar is 8.75. If we didn't do that, if we didn't do the steps we did last time, they would change. Upper control limits, lower control limits, they would all change. So let's look at that. We have like number 24 is out of control limits, and also 31, I think 32, 33, 35, I guess this is, let's see, this is 34, sample 34, test 1 failed. So we are gonna mostly look at the test 1. So these are probably test test failed. It is 8, sample 32. It shows the test number here too. These are all test 1 that's failed in R chart. So we have the test results. So in the test results, it's gonna show how many points are have failed. 1, 2, 3, 4, 5, 6, 7 numbers. 7 points failed. Let's check which sample does this belong to. This is sample 25. Let's check that. This is sample 24. Okay. So if we look at the first R chart, so 7 samples, 7 samples have failed. I mean, points have failed. So we close this. Let me open up the last picture. I will double check. The point. Okay, so I'm going to just look at the R chart, and I have the 7 points that are failed. Okay, in question, so that's the end of question 21, but in question 22 we will continue to work on that. I will continue 22 here because it's a continuation. So in question 622, what does it say? Question 622, let's see. Okay, it says, reconsider the data presented in exercise 621, rework both parts A and B of exercise 621 using Xbar and S chart. So this is going to be a comparison between Xbar and R chart. And before I do, actually, I should tell you that we should also add a name to it. Okay, it's always good to remember. Okay, charts for 35 samples. Okay, we click on that, and okay, so next we want to work on, so let's send these results to our let's see, where's that? Okay, do we have it bigger? No. Okay, I want to send this to the Word, and I want to also send these results to Word so that I have them in my work as well. And the data sets and the graphs, I want to send them to. Just want to make sure that they are there. And where are they? Okay, so I'm gonna send it. Okay, this is the charts for the first 20 samples, so let's send it to there as well. Okay, this is one. I'm gonna close it, and then I'm gonna also send my last graph. It shows no, let's close this. I don't need this anymore. And I want to send, Okay, let's see. I want to see my graph. Now I am looking for the one that I gave the name to. I think it was here. Where is it? Make it smaller. All of these graphs. Yeah, charts for 35 samples. So I'm gonna send this to the Word, and it's already sent, and I closed it. You can save it in a project as well. Okay, here's my data. Okay, let's make it smaller. So I have the picture for both. Okay, so I'm gonna continue with 22. So I'm gonna do stat, control charts, variables charts for subgroups, Xbar-S graph. All observations for a chart are in one column. Okay, I'm gonna do this for 35 samples. So I'm gonna choose '21 again because everything is in there. Right. So subgroup size is 5 fixed. Xbar-S options. Let's see. Mean and standard deviation. I have to state the same. Okay. 79.53 it was, and let's see what the other one was. 3.7618. 3.7618. Okay, estimate. I didn't omit anything yet. Okay, so I wanna just see. I wanna use just 1 to 20. The rest are gonna stay the same test, all tests. So click OK. Click OK. Okay, we compare. So let's add a name. Okay, Xbar-S chart for 35 samples. But of course, we keep the control charts for with respect to the first 20. Okay, so as you see, Xbar-R is 79.53. S-bar is different, of course, but that's fine. So let's count the number of. So we look at the S chart first. Here it is. So subgroups used for calculations 1 to 20. That's what it says. Okay, so let's count the number of points failed with respect to test 1. 1, 2, 3, 4, 5, 6, 7, 8. 8 of those. Okay, 8 of those. In the previous one, our chart was able to detect only 7 points. So S chart is much better. So it detects more. It detects the change in process variables more quickly than the R chart. Okay. So the points that are entered here, for example, number 24 was also detected in Xbar in the previous one, but here we have 22 added to the list. Okay, so that's good. That's the advantage. Let's see the test results. Okay, where is it? So keep that in here. So I will actually let's send it. Okay, let's send this first to our Word file, and send our results to Word file, and also send the this graph to the Word file also. So let's check our Word file. So we have the results. So test results for Xbar chart. See, so let's get the S chart first, as always. So 1, 2, 3, 4, 5, 6, 7, 8 points failed in S. If we compare this to R results, where are they? Yeah, 1, 2, 3, 4, 5, 6, 7. So our chart wasn't able to detect, I think, number 22. Okay. Alright. And yeah, so we are gonna say, so we will say S chart detects the change in process variability more quickly than the R chart. C point C sample 24 C sample 22. Okay. That's it.